All right, Gen Chem, we are going to start layering on balancing equations by also talking about different reaction types. So there are 5 main types of chemical reactions that we're going to talk about today. And we will learn how to spot them, hopefully see the patterns. So the 5 reaction types that we have are right here. We have synthesis, decomposition, single displacement, sometimes called single replacement, double displacement, also sometimes called double replacement, and combustion. Okay, I just want to go through a few ideas first. Synthesis. I want you to think in your mind, what does it mean to synthesize something? Hopefully you said it means to make something. So if I have a synthesis reaction, I am taking simple things and I am putting them together to make a more complex thing. Okay, number 2, what does it mean to decompose? You talked about decomposition in biology. So hopefully you talked about when something decomposes in biology, we're breaking down that material into simpler things. So decomposition is exactly that. We're taking a complex thing or a relatively complex thing, and we're breaking it down into simpler things, sometimes even down to the elements. Okay, single displacement. It's where I have one element that replaces or displaces another element in a compound. So I call this my mean girls reaction, and you'll see why in just a minute. And then double displacement. This is where I have 2 things that are switching places. So essentially in a double displacement reaction or a double replacement reaction, every single thing in that reaction is switching partners. And then combustion. Combustion, we usually think of fire, explosions, and things like that. It's actually just the burning process between carbon, hydrogen, oxygen that always creates carbon dioxide and water. Okay, so let's go into these. So synthesis. Here's our generic equation. We have x plus y equal xy, or reacting to produce xy. Notice we have simple things here in x and y, and we're putting them together to make a more complex thing. That is what synthesis is. Okay, so here we go. Combination of elements or compounds to form one new, I should say, more complex compound. Okay, so we're making something that is more complex than what we started with. Okay, so I have iron right here, and I have oxygen, and I'm putting it together in terms to make iron 3 oxide. Notice I didn't just write FeO2. Why not? Why didn't I just put them together? Because we have to be aware of the charges. Remember when we made our ionic compounds and when we put the compound together, we had to put the compound together in such a way that the sum of all the charges equaled 0. So all of the positives plus all of the negatives all together had to equal 0. So this is what we were doing with this. When iron acquires a charge, it acquires usually a +3 charge. Not always, but it's usually a +3 charge. And oxygen, let's see, I should probably get my periodic table out so that you guys can see. Where is my periodic table? There we go. Let's get this out. So iron right here, if you look at this periodic table, it tells you the charge that iron can acquire. It can acquire a +2, a +3, or a +6. It usually acquires a +3. So we're going to usually use it as a +3. Oxygen acquires a -2 charge. Okay? So when we look at this, we're going to say that iron has the +3 charge, and we're going to say that oxygen has that -2 charge. So how many irons do I need to put together to make it with the oxygens that are -2 to make it all add up to 0. So what we have to do is we need to look at these charges. We've got a 3 and a 2. What is the least common multiple of 3 and 2? Did you say 6? It is 6. Okay, so how many positive 3s do I need to get to a positive 6? Yes, I need 2 irons to do that. And how many -2s do I need to get to a -6? I need 3 oxygens to do that. So that's why I wrote the formula Fe2O3 so that I could balance the charges. Okay? Now let's look at sodium and chloride. Once again, I have to be aware of the charges that these are going to acquire when they become ions. So let's look at our periodic table. So sodium, that's going to acquire a +1 charge. It's in that first column. So we know that's a +1. Chlorine, because it's in the halogen column, it's going to acquire a -1 charge. Okay, so sodium will acquire a +1 charge. Chlorine will acquire a -1 charge. What's the ratio that we need to put them together with to make it add up to 0? 1 sodium and 1 chlorine. +1 plus -1 equals 0. So there's our equation. Now, what we have to do is we have to go back and balance this. So let's look at this. I've got 1 sodium and I've got 1 sodium. I'm okay here. I've got 1 chloride and I've got 2 chlorides and I've got 1 chloride. So I need to go and I need to double this, which means I need to go and double my sodiums. Now, hold up. I see that I didn't balance the one up top. So let's go back and balance the one up top, the iron. So let's see. I've got 1 iron here. I've got 2 here. So let's balance that. I've got 2 oxygens and I've got 3. What's my least common multiple between 2 and 3? 6. So I need to multiply my O2 by 3 to get 6 oxygen. And I need to multiply my Fe2O3 by 2 to get 6 oxygens. So 2 times 2 means I actually have to go back and I need to put 4 irons there. Okay? So if you noticed, we pay attention to the charges. So we write the charges of the ions. We write then the correct formulas for the ionic compounds. And then after we do that, then we go back and we balance the skeleton equation. Now, a skeleton equation is just the equation with the formula. It doesn't have the coefficients in there, okay? So it's actually a 3-step process. We have to get the charges, then we have to write the correct formula. Then, once we've got the correct formulas written, then we go back and we balance the equation, okay? So calcium and oxygen. Let's look at calcium and let's look at oxygen. So calcium's in our second column, so it will have a +2 charge, and oxygen has a -2 charge. So let's put in those charges here. So we have a +2 and we have a -2. So what ratio am I going to need? +2 plus -2 does equal 0, so I just need 1 of each. So 1 calcium, 1 oxygen. Okay, so I've got my skeleton equation. Now I'm ready for balancing my equation. So I've got 1 calcium, 2 oxygens, 1 oxygen. So I need to put a 2 in here, which means I need to go back and put a 2 in front of my calcium. Okay, and then sodium oxide plus water makes sodium hydroxide. So this is already written, so I really only have to pay attention to balancing this. I've got 2 sodiums, got 1 sodium here. So I'm going to double this up. I've got 2 oxygens. 2 times 1 gives me 2, and I've got 2 hydrogens. So I just needed to put a 2 in there. Okay, notice on all of these synthesis reactions, I'm taking simple things. They could be just straight elements, or they could be simple compounds, and I'm putting them together to make something more complex. Okay, that's what synthesis is. Okay, let's go on to decomposition. Decomposition is exactly the opposite. My generic equation is taking x and y and breaking it down to x plus y. So I'm taking something complex and I'm breaking it down. Okay, so decomposition is the exact opposite of synthesis. Okay, so here, decomposing a compound into 2 or more compounds or elements. Let's balance these equations. I have sodium chlorate. It's decomposing to sodium chloride and oxygen. So notice I've got 1 compound here and I'm breaking it up into simpler things. So let's look at each element by element. So I've got sodium, 1 sodium, I'm okay there. 1 chloride, 1 chloride, I'm okay there. Here I've got 3 oxygens and here I've got 2. So I need to find my least common multiple between 2 and 3. And that is, yes, 6. So I need to multiply this by 2 to get me 6 oxygens. And I need to multiply my oxygen by 3 to get me 6 oxygens. Now I need to go back and I need to change my coefficient in front of my sodium and chloride because this gave me 2 sodiums and chlorides too. Okay, now we're done. It's all balanced. Now let's look at the calcium carbonate that's decomposing into calcium oxide and carbon dioxide. Okay, so I've got 1 calcium, 1 calcium. I'm okay. 1 carbon, 1 carbon, 3 oxygens. 1 oxygen plus 2 is 3 oxygens. This balances without putting any coefficients. Now, remember, even though I don't have any coefficients written here, 1 is implied. Just like if I have x plus y equals z, this implies that I have 1x, 1y, and 1z. Okay? All right. Next up, I have sulfuric acid decomposing to water and sulfur trioxide. So let's balance this. I've got 2 hydrogens. I'm okay here. 1 sulfur, 1 sulfur. 4 oxygens. 1 plus 3 gives me 4. That is another equation that I don't need to put coefficients in. Remember though, a coefficient of 1 is implied though. Okay, and here, last but not least, I've got mercury 2 oxide decomposing into mercury and oxygen. So I've got 1 mercury, I've got 1 oxygen and 2 oxygens. So I need to double this up so I can have 2 oxygens, which means I need to double up my mercury. Okay, any questions on decomposition? Decomposition is always about breaking something down into simpler things. Okay, single displacement. Here is our basic pattern. I have X all by myself, and then I have a compound AY. And then once the reaction is done, A is by itself, and I have a compound XY. Notice X gets together with Y, and A gets broken away. So I'm just switching one element with another. Okay, that's why it's single displacement. Sometimes it's also called single replacement. Okay, I call this the Mean Girls reaction. I don't know if you guys have ever seen the movie Mean Girls, but in it, the main character, the protagonist, Katie, comes into a new school. At the beginning of the year, Katie is all by herself. And I think she spells it like that. I can't remember. And at the beginning of the year, we have the anti-protagonist, if you will, Regina George. Regina is the queen bee of the school. At the end of the year, though, Katie comes in and becomes the queen bee, and Regina is left kind of by herself. Okay, so we're just kind of switching places. That's what single displacement is. Okay, so let's look at this next one. Actually, before we look at this, I want to tell you a few things. So when we do single displacement, positives replace other positives, and negatives replace other negatives. So what you really need to do is on the step that we put in the charges that these will acquire when they're ions, we need to see if we have two positives that can switch places, or we need to see if we have two negatives that can switch places. Okay, and that's how you're going to decide what's getting together with what. Okay, so let's look at iron. So iron, we said up top, let's go to the periodic table. Iron usually has a charge of +3. So we're going to have it have a charge of +3 here. And copper here has a charge of +2. So if I look at this copper, it can have a charge of +2 or +1. It has a charge of +2 here. And the reason I know it has a charge of +2 is I've got two nitrates. Nitrates by themselves, one nitrate at a time, is going to have, it's going to have a charge of -1. Okay? So it will have a charge of -1. So my question here is, do I have two positives that can switch places with each other? Or do I have two negatives that can switch places with each other? I have two positives. I have the +3 and the +2. +3 iron and the +2 copper. They're going to switch places. So if I have a +3, how many nitrates that are -1 do I need to put with that iron? +3 plus 3 -1s equals 0. So I'm going to need 3 nitrates. And remember, when I need to multiply a polyatomic, I've got to put parentheses around it. So I'm going to need 3 nitrates, and then copper will be by itself. Okay, so there's my skeleton equation. Now, once I've got my skeleton equation, now I'm going to go back and I'm going to balance this. Okay, so, excuse me, I've got 1 iron and 1 iron. I've got 1 copper and 1 copper. So far I'm okay. But here I've got 2 nitrates and here I've got 3. My least common multiple between 2 and 3 is 6. So I need to multiply my coppers by 3. And I need to multiply my iron nitrates by 2. Which means I also need to go back and fix my iron and my copper. So I'm going to fix my iron by putting a 2 in front of it, and I'm going to fix my copper by putting a 3 in front of it. Okay? So let's look at this next one. Zinc. I have zinc. What charge can zinc acquire? A +2. Okay, so zinc is going to acquire a +2 charge. And let's see, hydrogen has a +1 charge when we are usually making ionic compounds. So this is a +1. And sulfate, SO4, if you look up on the polyatomic sheet, this is a polyatomic, and it has a -2 charge. Okay, so our next question is, Do I have two positives that can switch places with each other, or do I have two negatives that can switch places with each other? I have two positives that are going to switch places with each other. So we've got to figure out the ratio between zinc and sulfate then. So zinc is a +2, sulfate is a -2, so I need one of each. ZnSO4. And then hydrogen is going to be left by itself. And notice I'm writing H2 because hydrogen is diatomic. Remember, we have 7 gases that are diatomic, that when they are elemental or by themselves, they come in groups of 2. And those diatomics are the following. We have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. If I put them together in this order, they spell out Brinkelhoff. So that's how I remember what elements are diatomic. Okay, now let's go back and let's balance this. 1 zinc, 1 zinc. 2 hydrogens, and 1 sulfate group, and 1 sulfate group. We're good. This balances by itself. All right, let's look at this next one. I've got chlorine, sodium, and bromine. So let's look at the charges here. So sodium is a +1, chlorine is a -1, and bromine is also a -1. So let's put in those charges. So chlorine, -1 individually, sodium is a +1, and bromine is a -1. So, question, do I have 2 positives that can switch places, or do I have 2 negatives that can switch places? I have negatives that are going to switch places. So chlorine is going to get together with the sodium. What ratio? +1 plus -1 equals 0. So I need 1 sodium and 1 chlorine. We will make sodium chloride, otherwise known as table salt, and then bromine will be off by itself. And notice I wrote Br2 because guess what? Bromine is one of our diatomic or our Brinkelhoff gases. Okay, now I get to go and balance this. Okay, I've got 2 chlorines, and here I've got 1. So I need to multiply this by 2. I've got 1 sodium, and I've got 2 sodiums, so I need to multiply this by 2, and 2 bromines with 2 bromines. Okay, I'm good. All right, next, aluminum with silver nitrate. So aluminum, let's look at our periodic table. Aluminum has a +3 charge. Silver usually has a +1 charge, so I'm going to call it +1. So aluminum is a +3, silver is a +1, and nitrate is NO3 -1, if you look up on your polyatomic table. Okay, so here we go. We've got aluminum and silver nitrate. Okay, silver and nitrate are going to get together 1-to-1, +1 plus -1. Okay, next question. Do I have 2 positives that can switch places, or do I have 2 negatives that can switch places with each other? I have 2 positives. So the aluminum is going to get together with the nitrate. What ratio do I need? +3 plus 3 -1s is going to get me to 0. So I need 1 aluminum and I need 3 nitrates. And then silver is going to be off by itself. Okay, notice all of these. We're switching one element out for another. Okay, so let's go back and balance this. I've got 1 aluminum, 1 aluminum. I'm okay. 1 silver, 1 nitrate group, 3 nitrate groups. So I need to multiply my silver nitrate by 3, which means I need to multiply my silver by 3. Okay, so single replacement or single displacement, we're just switching one element for another in a compound. We're just trading partners. Just one of them, though. Okay. And then double displacement, we have everyone switching partners. I start with AX, and then by the end of the reaction, B is with X. And I have BY. By the end of the reaction, A is with Y. So everyone is changing partners. So very much so, we will have this pattern where we have A getting together with Y and B getting together with X. That is the pattern of double displacement. Sometimes it's called double replacement. Okay, and in a really old textbook, you will sometimes see it called metathesis. Okay, I don't know if you guys have ever seen the Disney movie Enchanted. I just misspelled that. Let's try to spell that again. Enchanted. It's kind of a cartoon and live action movie. We have a couple in New York, and we have a couple in Fantasyland. And the princess in Fantasyland is chased through this kind of wormhole thing by an evil witch, and she pops up through a manhole in Manhattan, New York City. And Prince Charming comes chasing after her to try and save her from this evil witch. So we have Princess and Prince Charming, and we have a New York guy and girl. And by the end of the movie, Princess is with New York guy, and Prince Charming is with New York girl. So everyone switches partners in a double displacement or a double replacement reaction. Okay, that's why I call it the enchanted reaction. So remember, when we make ionic compounds, we have to have the sum of the charges equal 0, positives replace positives, negatives replace negatives. Okay, so just like before, the first thing is always to put in the charges. The second thing is always to write the ionic compounds. Remember, the sum of all charges has to equal 0. And then the third thing is to balance the equation. Okay, so that's always the step. So let's put in charges first. All right, we've already used all of these elements again before, but let's look at them again. So silver is a +1, sodium is a +1, and bromine is a -1. And then the nitrate group that we're using is also a polyatomic that is -1. Okay, so we have a +1 for silver, we have a -1 for nitrate, we have a +1 for sodium, and we have a -1 for bromine. Okay, so silver is positive. It has to get together with a negative. The only other negative here is bromine. Now we need to decide on the ratio. +1 plus how many -1s equals 0? 1 to 1, right? 1 silver, 1 bromine. Okay, remember to always write the positive ion first. Always, always. Okay, and then the next thing, we need to look at sodium. Sodium is positive. The only other negative it can get together is nitrate. +1 plus -1 equals 0, so we are going to have 1 of each as well. Okay, so there's our skeleton equation. And this one is pretty easy because we just have 1 of each of these and we have 1 of each of these. This one balances without any coefficients. Remember, coefficients of 1 are implied. Okay, notice how everyone switched partners. All right, this next one, calcium. Calcium has a +2 charge. Okay, right here, +2. And then acetate On our polyatomic chart, this is acetate. This is a -1. Ammonium is part of our polyatomic chart. It has a +1 charge, if you want to look it up. And carbonate has a -2 charge. Okay? So calcium, the only other negative it can get together with is carbonate. +2 plus how many -2's equal 0? 1 to 1, right? 1 calcium, 1 carbonate. All right. Then notice we always write the positive ion first. So I'm going to start off with ammonium. +1 plus how many -1's equals 0? +1 plus 1 -1. So I need 1 of each. So ammonium acetate will just have 1 of each. Okay, there's my skeleton. Now I need to go back and balance. Okay, 1 calcium, 1 calcium. I'm okay. 2 ammoniums. I only have 1 ammonium here, so I need to double this up. Okay, not ammoniums, acetates. 2 ammoniums here. 1 carbonate, 1 carbonate. Notice how, because the polyatomic ions don't break up, I balance the polyatomic ions as a group. It's so much easier to do it that way. All right, let's put in our charges. Lead 2, Pb plus 2, and nitrate. Nitrate is NO3, -2. This 2 tells me that it's +2. Sodium, we've already dealt with sodium. Sodium is a +1. And iodide. Iodide is part of our halogens, so it is a -1. Okay, so let's look at the ratios that we're going to need. +2 plus how many -1's is going to equal 0? I'm going to need 1 lead, and I'm going to need 2 nitrates. And sodium iodide, I just need 1 of each. Okay, so let's going to start with the lead. +2 plus this -1, right? That's the only other negative here. So what ratio? I'm going to need 1 lead and 2 iodines. +2 plus 2 -1's equals 0. And then sodium is going to get together with nitrate. What ratio here? +1 plus -1 is equal to 0. So 1 to 1 ratio. Okay, there's my skeleton. Let's go back and balance this. 1 lead, 1 lead. 2 nitrate groups, 1 nitrate group. So I need to double this up. Okay, 1 sodium, 2 sodium. So I need to double this up. 2 iodides, 2 iodides. Okay, so remember, balance the equation after you've put the skeleton together. Okay, this next one, we've got potassium. Potassium is in our +1. So potassium is +1. Gracious. Is this going to let me write? I see that I'm killing this word right here. Okay. And it's still not going to let me write. Okay, so potassium is a positive 1. Hydroxide Hydroxide is a negative 1.